Welcome to Lead Programmer. Today we are going to solve the question longest common subsequence. So we have been given two strings and we have to return the length of their longest common subsequence. And if there is no common subsequence, we return 0. So firstly, what we mean by subsequence. So let's say we have A, B, C, D, E. This is a string. Let's consider another string, let's say A, C, E, and let's consider another string, let's say A, E, D. Uh, Now we can generate the string ACE using the given string. How? We can do so by removing these two characters. So we generated a new string by removing a few characters from the given string, and doing so is essentially called generating a subsequence. So we generated a subsequence, so we created a new string ACE and it's a subsequence of the given string ABCDE. Now, one thing to take care while finding a subsequence is the order of the characters should remain the same. So that being said, AED is not a subsequence of ABCDE because E occurs after D and not before, and hence AED is not a subsequence. So, in the given question, we have to find a common subsequence between two strings, and we have to return the length of the longest common subsequence. So let's take the first example. We have A, B, C, D, E, and we have A, C, E. So the common subsequence between the two strings are A, B, C, E, A, C, C, E, A, E, and A, C, E. So these are the subsequences between these two strings. So we can generate A by removing this and this. We can generate B by removing, sorry, we can generate C by removing this and this, and so on. So we can generate AC by removing these characters. We can generate AE by removing these characters, and we can generate ACE by removing this character and this character. Now the objective of the question is to return the length of the longest common subsequence. So we can see that ACE is the longest with a length of 3, and hence this is what we return. In the next example, we have two strings, ABC, ABC. It's pretty obvious that the subsequence is ABC, and the length, and it's the longest because that's the length of the string, and the length is 3, so we return 3. In the next example, we have been given A, B, C, and D, E, F. There is nothing common between these two strings, and hence there's no common subsequence, hence we return 0. So how would we essentially solve this question? So let's say we have A, B, C, D, E, and we have A, C, E. So let's start by using the first character. We see that the first character is equal, so it will be a part of the subsequence. So essentially we can say that, okay, A will be a part of the subsequence. Once we have finalized that, we need to find the common subsequence in the rest of the string. So A, which is the same in both the strings, is common, and it is a part of our longest common subsequence. We definitely consider A because we are looking for the longest. So we will include all the common characters. So we have A and A, which is common. So we take A. So that will be in our longest common subsequence. And then we have to find the rest of the characters in the rest of the sequences. So we look at B, C, D, E, and C, E. So we have B, C, D, E, and we have C, E remaining. So A is gone. We check the first characters again. We see that they are not equal, which essentially implies that we have to try to find our subsequences between B, C, D, E, and E, this thing, or it can also be in C, D, E, and C, E. So we look at both these strings. Why do we do so? Because the common subsequence can we don't know which character to include. Will we include a character from the first string, or we'll include a character from the second string? So we essentially want to try including the B over here and the rest of the string, and omitting C over here, in the second string. So that's how we get B, C, D, E, and E. Or we also want to try omitting B, so that gives us C, D, E over here, and including the character over here, which is C, so C, E over there. And we repeat the process. So let's say in the second case over here, we see the C is common, so the C would definitely be included. And then we try finding the common subsequence between D, E, and E. So we see that this is not equal, and we kind of repeat the process. So this intuition leads us to how we would solve this problem. It's essentially dynamic programming, where let's write this in a different way. So let's say we have A, B, C, D, E. So we have that string over there, and let's say we have A, C, E. So just a different way of writing the two strings. We look at starting from the top portion over here. This top portion essentially implies the length of the common subsequence of A, B, C, D, E and A, C, E. So similarly, if we take some other point, let's take another point over here. This would essentially imply the longest common subsequence between C, D, E and E. Okay, so now that we understand the meaning of this grid, essentially it's a 2D dynamic programming problem, and hence we have a 2D grid over here. So let's say we start from here because we want to find the common subsequence between this whole word here and the whole word here. So how do we find the length of the common subsequence over here? So the length of the common subsequence over here would be, so A and A are equal, so they will be a part of the common subsequence. So the A contributes to one of to a length 1, plus we would have to look at the common subsequence between the remaining part of the strings. So we previously demonstrated that we if a character over here is equal, we look at the remaining part of the string. So we look at B, C, D, E, and we look at C, E. So to do that, we would have to move diagonally over here. So essentially the value over here would be 1 plus whatever the value is at this location over here. Now how do we find what's the longest common subsequence over here? So over here, it essentially means that we find the longest common subsequence between B, C, D, E and C, E. But as we saw, B and C are not equal, which means we have to look at two possible strings. The first possibility is we look at C, D, E and CE. That is, we omit the B, so we look at CDE and CE, or we omit the C, which means we look at BCDE and E. So we either look over here, which is CDE and CE, or we look over here, which is BCDE and E. And how do we decide what value would go in this particular location? It will essentially be the max, because we are looking at the longest common subsequence. So it's essentially the max of what we get here and what we get here. So the max of those two values would essentially come at this cell over here. Okay, so once we get a value over here, so let's evaluate this. So again, being at this location means finding the longest common subsequence between E and BCDE. So essentially, we see B and E are not equal. So again, the value over here would be the max of the value over here and here. Oh, we see that we reach here, but there is no character corresponding to that location in the row. And that's because being at this position over here means finding the longest common subsequence between BCDE and an empty string. So what's common between an empty string and BCDE? Nothing is common, and hence by default we would have the value of 0 over here. Same implies over here, because this is empty, and there can be no common substring between an empty string and any other string. So we'll have all zeros in this row over here. Similarly, over here we have an empty string. So what's common between an empty string and any of the possible combinations over here? There's nothing common. So we'll have all zeros over here as well. Okay, so now we established that. We come back to where we were. So we were at E over here. Now, since E and B are not equal, we'll find the max of the longest common subsequence over here or over here. So for this location, being at this particular location means finding the common subsequence between E and CDE. So we check, is C equal to E? Is not. So here is essentially the max of whatever we have over here, which is 0, and whatever we get over here. Again, we check D and E are not equal, so whatever over here is essentially the max of 0 over here, and whatever we get here. Here we check it's E and E, so it's essentially 1 plus whatever is over here. Now there's nothing common between an empty string and an empty string, so it's 0. So it's 1 plus 0, which is equal to 1. So we have a 1 over here. And therefore now we can say, okay, the value over here will be 1, because that's the maximum of 1 and 0. Same goes here, so it'll be 1 here, it'll be 1 here. And then we haven't evaluated this tree over here, so you kind of get the idea. So we'll have something similar here. So over here we see C and C is equal, so it'll essentially be 1 plus whatever value we have over here. So over here we have a value of, in this diagonal over here we have a value of 1, so it'll essentially be 1 plus 1 over here. So 1 plus 1 is equal to 2. So this particular cell would be the maximum of 2 or and 1. So the maximum of 2 and 1 is obviously 2, so we'll have a value of 2 here. So the value over here will be 1 plus whatever value we have over here. The value over here is 2. So the value over here will be 1 plus 2, which is 3. And that's the output we receive. So you might be wondering, all right, so we can run this logic starting from the location 0, 0. So 0, 0, and going all the way to the bottom. Sure, we can do that. We can start over here and go all the way to the bottom, but you realize that there might be repetitive calculations. So for finding the value over here, we had to find value in all these cells. Now for finding a value over here, we'll have to recompute the value of many different cells. So for example, when we start calculating the value of over here, we see a and b are not equal. So we want to find the maximum of the value over here and the value over here. But the value over here was computed in the previous step. But we don't want to calculate it once again. Otherwise, it's like a brute force solution. So one way to offset that is start at the bottom right. So maybe start over here. We already know that these values are going to be 0, so we don't touch them. We start over here, and we go about calculating the values in reverse order, because one thing to notice is we either go diagonally downwards or we go to the right or bottom. So if we start over here and go from right to left, from the last row to the top row, then we don't run into issues. So any value that we might potentially need would already be computed in the previous step. So and that gives us a good time complexity. It just gives us a time complexity of the order of the length of the strings that we have, because we don't want to recompute the values. Okay, so let's look at the code for this to understand this better. So it's a pretty simple code. The first step is to construct the 2D matrix that we had. So let's take this as a running example. So let's just copy this and let's get this as a running example over here. So the first step would essentially be to initialize our array. So to do that, we essentially have this statement right here. So this is like a Python logic where this particular part over here is responsible for generating this, something like this. So let's say the length of text2 is 3, so it will generate something like this, and we want to repeat this particular row, the length of so I made it 4 zeros because we are doing length of text2 plus 1. So length of text2 is 3 and length of text2 plus 1 is 4. So we generate this first, and we want to repeat it for the length of text1 plus 1 number of times. So we want to repeat it 6 times. So we have 1, 2, 3, 4, 5, 6. So we have something like this. So we repeat it for a total of 6 times, and this is essentially the 2D matrix that we had. Okay. Now one thing to easily confuse, and I made the same mistake, is it's very tempting to kind of nest these multiplication statements. So we have this statement which gives us a row, and it's very tempting to just have a multiplication over here and do that for those many columns. But this wouldn't work because Python essentially copies the address. So if you, for example, if you make any change over here at 0, 0, that change would be propagated to all the columns, all the rows. So to avoid that, this is the correct syntax to use. You can give it a read, and it's easy to get around that. So one thing to note is the number of columns is the length of the text1 plus 1, and the length of columns and the number of columns is length of text2 plus 1. Now, as mentioned, we want to go from the bottom right all the way to the top left. So to do that, this is the logic where we want to start from the length of text1 minus 1. So we want to start, and length of text2 minus 1. So we want to start from this location over here, and we're going to keep going back. So this is the syntax in Python. So we have that. So for a given I and j, we want to compare the so we want to compare which character it is. So let's say we are at this particular location over here. So for this location, we want to compare is b equal to c, or if we are at this location, we want to compare is a equal to a. So if a is equal to a, so we had if a is equal to a, then what would be the value at this location? It'll be 1 plus whatever the value is at its diagonal, right over here. So to do that, we essentially have dp at ij. So if it's equal, if the characters are equal, then the value over there would be 1 plus whatever value is in the cell diagonal to it. So dp at I plus 1, j plus 1. And if they're not equal, so like in this case, we saw b and c are not equal, then in that case, the value at this cell would be the maximum of the cell to its right and the cell to its bottom. So to do that, we do, it's essentially the maximum of the dp at I plus 1j and dp at I j plus 1. So once this loop runs, we'll essentially have all the values populated for all these rows and columns. So once that's done, our final answer would essentially be the value over here, because recall that this particular cell means the longest common subsequence of this entire string and this entire string, and that's what we want. Hence, at the end, we can just return dp at 0, 0. So that's the final, so that's the solution. The time complexity would be the big O of n times m, where n is the length of the first text, m is the length of the second text. Because as you saw, we had a 2D matrix corresponding to those particular lengths. The space complexity is also going to be the same, because we have a 2D matrix in which we store values. So I hope you found this helpful. Please like the video, subscribe for more. Thank you.